Here we have a SAT math question on quadratic function. Okay, let's go the question. Y equals to x square positive 10x positive 16. The equation above represents a parabola in the xy plane. Which of the following equivalent forms of the equation displays the minimum value of y as a constant or quotient? Okay, so whenever I want to write a quadratic function which displays the minimum value or maximum value of y, so the quadratic function has to be in the vertex form, that is y equals to a times x negative h whole square positive k. So here, this is a vertex form, a standard form of a quadratic function. So in this vertex form, if the value of a is greater than 0, then the parabola opens up and will have a minimum point, and the minimum point will be h comma k, that is nothing but the vertex. And in this vertex, y coordinate k represents the minimum value of y. Okay, so here, so to get the quadratic function which displays the minimum value of y, so we have to identify the quadratic function which is in vertex form in the given options. So in the given four options, only in option C and option D, we have the quadratic functions in vertex form, that is in the form y equals to a times x negative as a whole square positive k. So the first two, A and B, are not in vertex form. So we can reject option A and B. So option C or option D may be correct. So for that, what we need to do is we have to write the given quadratic function in the vertex form, that is y equals to a times x negative as a whole square positive k. Okay, now let me take the given quadratic function, that is y equals to x square positive 10x positive 16. Okay, so to write the given quadratic function in vertex form, so we have to consider the two basic algebraic identities. So they are a square positive 2ab positive b square is equal to a positive b the whole square, and a square into 2ab positive b square is equal to a negative b the whole square. So the trinomial over here and the trinomial over here are called perfect square trinomials, because each of these trinomials can be written as a square of the binomial. Okay, so whenever we have an expression, I mean a trinomial in the form a square positive b positive b square, it can be written as a positive b whole square, and if the 2ab is negative, then it will be a negative b the whole square. So because in vertex form on the right side we have the square of a binomial, so that's why I want to write the given quadratic function, I mean the expression over here, in terms of the square of a binomial. Okay, so for that, what I'm going to do is I'm going to do some changes in the given quadratic function. That is, I'm writing this x square as it is. That means I consider this x square for this a square. So, and the next term has to be positive 2ab. So we have 10x over here. So already we consider this x square for a square. That means comparing this x square a square, we have x for a. Then 2ab means 2 times, and for a we have x. So the place of a we have to write x, and we have to write some value over here, so that the simplification of this one equals to 10x. So what value should I write over here? So I have to write 5. So that 2 times x times 5 will become 10x. Because my aim is to get the trinomial in the form a square positive ab positive b square over here. That's why I'm writing 10x in the form 2 times x times 5. Now it is in the form of a square positive 2ab. So what do we have for b? We have 5 for b. So according to the trinomial over here, we must have b square. That means we need 5 square over here. But 5 square is there? No. Is it possible to write this 16 in terms of 5 square? No. So what we can do is we can add 5 square, because I need 5 square. Okay, when I add 5 square, the original stuff will change. So to balance the addition of this 5 square, I subtract 5 square. At last, I'm taking this positive 16. Okay, I made some changes in the given quadratic function. Even if I simplify this stuff, it must be equal to the original stuff x square positive 10x positive 16. Okay, now we have to make sure, let's check that. So we have x square, and the simplification of this one is 10x. And positive 5 square, negative 5 square is a 0 pair. It will cancel out, and we have positive 16. So the stuff I have over here is equal to the original stuff. Okay, now y equals to, and this particular expression, I mean x square positive 2 times x times 5 positive y square is exactly in the form of a square positive 2ab positive b square. Instead of a we have x, and instead of b we have 5. So for a square positive 2ab positive b square, we can write a positive b the whole square. And for this x square positive 2 times x times 5 positive 5 square, we can write x positive 5 the whole square for this trinomial. And we have one negative 5 square. Negative, the value of 5 square is, I mean negative can be taken as it is, because this square is applicable only for 5. So this negative will come as it is, and the value of 5 square is 25 positive 16. So y equals to x positive 5 the whole square. When I simplify this one, I'm getting negative 9. So now I got the given quadratic function in vertex form, so which displays the minimum value of y over here. So the minimum value of y is negative 9. So we find this vertex form of a quadratic function in option C. So the correct answer choice for this question is option C.